Hi learners, welcome to my channel. Today in our podcast class, let's learn about Doppler's effect in light. Yes, according to Doppler's effect, whenever there is a relative motion between a source of light and observer, the apparent frequency of light received by observer is different from the true frequency of light emitted actually from the source of light. What do you mean by apparent? Yes, the meaning of apparent is seems to be true or maybe may not be condition. Understood? Now you see here you have a source of light and observer. Both are not at rest. If they are at rest, then the frequency what the source is emitting will be absorbed as the same frequency by the observer. But when source of light is moving and observer is at rest, or source of light is at rest and observer is moving, or both the source of light and the observer are moving, they can move towards each other or far away from each other. Okay. Yes, if these are the conditions, then the frequencies emitted by the source of light will be different. Okay, so as far as the observer's concerned, the frequency will be different, but that is not true. So you call that frequency as apparent frequency of light received by the observer. Let's go again. According to Doppler's effect, whenever there is a relative motion between a source of light and observer, the apparent frequency of light, there is a change in the frequency, isn't it? So frequency of light received by the observer is different from the true frequency of light emitted actually from the source of light. Listen learners, when source of light and observer are moving away from each other, there will be increase in wavelength of the light emitted by the source of light. Okay, when source of light and the observer are moving closer to each other, then the wavelength of the light will be decreased. Okay, that is called apparent decrease in the wavelength, not true decrease. This apparent increase in the wavelength is referred as redshift, and the apparent decrease in the wavelength is referred as blueshift. Yes, astronomers call the increase in wavelength due to Doppler effect as redshift, since a wavelength in the middle of the visible region of spectrum moves towards the red end of the spectrum. Okay, when waves are received from the source moving towards the observer, there is an apparent decrease in wavelength. This is referred to as blue shift. You see learners, there is no much change. There is a fractional change in the frequency. Okay, this fractional change in the frequency is given by delta nu divided by nu, which is equal to minus v radial divided by c, where v radial is the component of the source velocity along the line joining the observer to the source relative to the observer. V radial is considered positive when the source moves away from the observer. Okay. The above formula what I said is valid only when the speed of source is small compared to that of light. Now let's move on to the applications of Doppler's effect in light. Yes, the first one is Doppler's effect is used in measuring the speed of stars and galaxies. They are used in measuring speed of rotation of the sun too. Often we need to estimate the velocity of aeroplanes, rockets and submarines. Okay, so we make use of Doppler's effect in light. We can see police use this property in radar boxes to track speed. That's all for today's session. Hope you have enjoyed the podcast class. Hope you have learned something. Happy learning. Do subscribe to my channel. Stay connected with me. Let's enjoy learning. Bye bye.